Hey guys, VapeyMcGyver here. We're going to have a look at the Innokin EQ. Oh, I was just bumping the camera there. Okay, Innokin EQ. That's what we're going to have a look at. What we're going to do is pull this device apart and see what's going on inside here. I kind of like pulling apart these little pod systems because they're so compact, and the Innokin devices at least have got some circuitry in there because it's adjustable output. So there's going to be a little board. There's obviously going to be a battery in here and a charge circuit. And I just want to have a look inside, see what it's like. I've got a quite big going on here for Friday night. Well, it's my Friday night. It's actually Thursday, but I got a long weekend, so sweet. It's not really a review. Not really going to review it. I don't really use pod systems personally. I prefer bigger systems like dual cell 18650 and a sub-ohm tank at the moment. Normally use an RTA, but loving this Freemax Mesh Pro. Mesh Pro? Yeah. Lovely little tank. Good thing. Yeah, so as far as like an actual reviewy sort of thing, I have used it. I quite like it for a little mouth to lung, but again, it's not really my deal, so I'm not well enough experienced to comment on that properly. Normally Innokin stuff is really good quality. They specialize in a lot of mouth to lung stuff. So the old T18, which I've got, a T20S, I've done a review, not a review, a test on that. Well made inside and performed really well. So yeah, keen to see what's in it. Now it's a bit of a tricky one because I don't know how to get inside this thing. There's no screws. There's no removable panels or easily removable. I'm guessing this panel inside here where the contacts are, I reckon that would be a kind of like a snap fit, like it'll have little clips or something going on in here. So it might end up ruining this device, but no big deal, and all in the name of science we want to see what's inside there. I don't know, I might pull the pod apart. Not too interesting. Okay, fast forward a bit while I muck around trying to get this apart. I'm not cheating here. Obviously I haven't opened it up yet, so I've got no idea how to get in, how it works. Alright, fast forward part. There's a sticker on top, and I bet there's going to be hidden screws under here. Well, that actually didn't help that much. There's two magnets there, now we can see, and still no screws. I was hoping there was going to be two screws under there, but there is not. Kind of don't want to stick a screwdriver through the battery or circuit. We don't want to destroy what we've come here to test, but just kind of getting a bit brutal with it, trying to get this out. Well, the screws could be under these magnets, but how on earth am I going to get them out? Well, I'm just making a total mess of this. I have no idea how this comes out. There's nothing coming loose at all. Even I tried to lift up on this, it's solid as a rock. Jeez, I got no idea. Obviously, it's completely ruined at this point. Oh, jeez. Dremel time. I've got this top plate loose now just by absolute brute force. Kind of see down into the board. It's actually a decent sized board in there. So I thought it would kind of just be all battery in there. Maybe just like a little board at the top, but it's kind of a substantial amount of board. I just still have no idea how this is actually secured. It's just bizarre. So sort of starting to come loose now, but oh man. Well, I'm just going to cut that piece off because don't really need that to be there. Yeah, still lights up. Haven't stuffed it yet. Just noticing here, in the absolute mess I've made, there is an O-ring. That's rubber for sure. Around that plate, looks like. That's pretty good. Good to see some juice ingress protection there. Yay, here we go. Aha, gotcha. Wow, that was so difficult. I think that's the hardest device to get apart I have seen yet. And I don't even know how it was so difficult. Looks like, gee, maybe glued. Some super glue in strategic spots, and then they've just stuffed the whole thing down inside, and there's been a rubber seal somewhere around that top plate. Okay, well there's yeah, there's the inner assembly out. Yeah, look, more sort of glue there. Yeah, I mean, there's absolutely no way this is user serviceable. Well, nothing we use is user serviceable anyway. But especially this, you're not going to be just taking it apart. If you've got any problems with this whatsoever, throw it out, get a new one. Well, don't throw it out. Take it to somewhere that recycles lithium-ion batteries, because that's not good to put in the rubbish. Okay, so we're seeing a little Innokin seal there on, been on a couple of devices I've taken apart so far. I guess a little quality seal. It's kind of cool to see. I like that. There's our just wires coming from, what's that, coming from the USB port. So obviously there's not going to be any firmware updates on this because there's nothing to update really. So you've only got power coming in. Yeah, you've only got power coming in from the USB socket. So data lines are just not connected to anything. Looks like there's a little lower board here with a couple of screws holding it in. Where is my screwdriver? Right in front of me. Okay. Finally got some screws to take out. Right, there's the lower assembly with the USB socket. Yeah, so it's a nicer USB socket arrangement than what we commonly see on these devices. So if you've watched the Sharon Mini disassembly video I did, I was talking about the USB sockets when they're mounted at a 90 degree and they're kind of prone to breaking off and flexing. And an alternative being better is when they've got the 4 pins and it's lying flat on the board, which is what this one is. So that's good. And you can even see there's the 4 little tags there soldered onto the board. Just gives it a bit more, well, it gives it a lot more strain release, strain protection, would you say? So yeah, just 2 wires coming off the USB socket and there onto the main board and soldered there and there. Wires obviously very, very thin, very small, but they feel decent. They don't need to be big wires, they're not carrying much current. So what we can do is we'll just pop out. Obviously we're just interested in the board assembly and the battery. What I want to do is test. I'm pretty sure Innokin's going to be spot on with what they say their specs. Well, they were with the T20, so no reason to believe they won't be with this one. But there's 2 power settings on this device, so we can test it. Just rig it up. It's pulse width modulated, so it might read a little bit funny. Might have to get the oscilloscope out or something, but either way I should be able to measure what's coming out of it, see if it's accurate. And the other thing I want to do is measure this internal cell and just see if that actually tests out to what they claim. I'd have to check the specifications. I think 800 milliamp hour, something like that. Either way, we'll have a look and we will actually put it on the West Mountain Radio computerized battery analyzer that I've got over there, and we can do a constant current discharge and see what it's actually putting out. So it's 3.7 volts, 2.96 watt hours, and do a calculation. I can't remember how to convert that to my brain's not working. It's been a long week. Convert that back to milliamp hours. So it's, I mean, if it was 3.7 watt hours, it's going to be no, okay, I'm not even going to guess. I'm just going to sound stupid. All right, having a look at the board here. The hand soldered parts look pretty decent. They're alright. The board itself, the board in the T20S was okay, not amazing, but you know, it's okay. Big fire button. That's interesting. It's actually really good. I like that. The board's still working. Hey, that's good. It's a quite a big tactile switch. So often they use really tiny little tactile switches, and I kind of think as far as switches go, kind of the bigger the better. The little tiny ones don't seem to take as much pressure, and probably fail after a lesser number of presses. So that's good to see that it's quite a big switch compared to other boards. I just don't normally see them that big. I'm a liar. Okay. What are we looking at here? What board is this? Aegis Legend. No, actually it's the same. Well, yeah, pretty much the same. Well, okay, talking about the up and down buttons, yeah, they're tiny. They're the ones I was thinking of. Yeah, fire button. Alright, standard fire button, never mind. Just have a look at these ICs, see if I can recognize anything on here. The charge circuit in the T20S was charge controller was a 5056, which is really commonly used, pretty much all-in-one charge controller. So it's just one IC, and only needs a couple of little extra components. And what it does is it handles all the charging duties. So all it needs is 5 volts in from USB, and it does a proper constant current and constant voltage charging. What would you call that? Charging method that works. Charging method for the cell, which is kind of what it should be doing, with a proper cutoff and a few other things like automatic recharge, slow charge in case the cell's over discharged, bits and pieces like that. It's quite a good little controller. So just having a look on board to see if one of these is a 5056. I can't quite see it. It doesn't look like it. And also, it's not going to look like a standard buck or boost converter, like not a normal DC converter, because I believe it is PWM, which is pulse width modulated. It's a slightly different way of altering the output power. So instead of actually having a flat DC coming out and actually changing that voltage level up and down, what you're doing is you're just taking the battery voltage and chopping it up, and then the size of the pulses you're just making bigger or smaller for how much power you want to put out. So if you just make 100% duty cycle, it's just putting out full battery voltage. If you want, say half the power, really, you reduce that pulse down to 50% duty cycle, and that's what they do. It's a simpler circuit to do. All you're doing is just switching the battery on and off rapidly. You won't notice it when you're vaping, but I can probably get up an oscilloscope graph of this, and you'll be able to see the pulses. And probably the pulses are going to be, I know the pulses are going to be wider when you're on the higher power setting, and skinnier on the lower power setting. So that means we're not going to see inductors, or there's not a whole lot of components really going on in here. There's just going to be probably a couple of little MOSFETs and a little bit of intelligence, so you get different colors, so you can select which output you want, the high or low. And there's going to be a charge circuit, but as I said, I can't see a number I recognize on here. Okay, well that'll probably do for the disassembly, I guess. There's what's inside your Innokin EQ. I'm not sure how they feel about me pulling apart their devices. The engineers, I know, is an engineer ever going to watch one of my videos? I doubt it. If anyone at Innokin is watching and sees their poor little EQ getting pulled apart, I think they'd really not enjoy seeing this pulled apart. But look, I kind of look at it this way: if there's a competitor, I'm not giving away their secrets. If there's a competitor that wants to pull apart an Innokin device, see what makes it tick, and then try to make their own copy of it, they're just going to buy an EQ and take it apart themselves. I mean, they're not going to get a great deal of information just looking at it off my video. So I'd kind of feel bad if I'm showing stuff they don't want to be shown. But the same token, if anyone's going to rip it off, they're just going to buy one for the $20 or whatever it is and have it in front of them, actually test it, and kind of nick it from there. But again, there's nothing too tricky about battery and a little PWM board. So you don't even really need to rip someone off for this sort of stuff. Anyway, okay. Look, what I'll do is I'll go do some testing on this, check the battery, check the board, see what it's putting out, see how good the battery is. May do another video, but I think I'll just put it in the Reddit post and attach this video along with it. This is while we're all set up here on camera. I'm just going to plug the USB into charge. Let's have a look at what current rate is actually going into this. It's probably going to be about a 500 milliamp, I'd say. Battery is sitting at about 3.9 volts. It does vary a little bit plus or minus, depending on how charged the battery is as to what current you'll see. Normally they want to charge a bit higher current when the battery is dead flat. Let's just plug him in and see. Okay, yeah, it's about what I expect. 467 milliamps. I've got my leads the wrong way around, but that doesn't matter. Yeah, that's pretty much what I thought we'd see. And we'll just pause for a second, and what I'll do is I'll just desolder this wire and I'll see what actual charging current to the battery that will be. It'll be around about the same on a single cell. Yeah, it should be a similar current as to what you're seeing going into the USB, what will be going into the cell. That's going to be pretty decent for it. Yeah, it is 800 milliamp hour. I did the conversion. My brain is fried. 2.96 watt hours at 3.7 volts does work out to be about 800 milliamps. Milliamp hour. So the label on the cell itself is labeled the same as what Innokin rates the device, which is good to see. They didn't sort of fudge any numbers, and Innokin wouldn't be the ones making this cell or labeling it. So yeah, they've taken the cell and just labeled the device as what they use, which is cool. Back in a sec. Alright, so what I've done here is just remove that positive wire. As I said, I've just got the meter on microamps. So the meter is in ammeter mode right now, and we're just measuring the standby current of the board, and that's measuring really low 8.3 microamps. So that is that's really good. That's not going to discharge the battery. It's going to take years upon years to discharge this battery, just by the standby current of this board. So that's good. That's good to see with the internal battery mods, because if they sit on the shelf for a while before you get them, you don't want the cell being dead, obviously, by the time you get it. If they sit on the shelf for a year, which is entirely possible before you get it, you don't want it damaging the cell, which has happened before. I think with I want to say dot mod, something with an internal battery. They were having issues where there was standby drawer and they were killing batteries while they were sitting on the shelf. So yeah, that's quite important. Super low. The battery is probably discharging itself quicker than what the board is. So that's good to see. What we're going to do then is swap to normal amp scale, and leave that set up as is, and we'll plug them into charge. We'll see what the charge circuit's actually putting into the cell. So it's about 470 milliamps into the USB port, or USB current, and very similar. So about 450 milliamp is the actual charging current. That's fairly high for an 800 milliamp hour cell. That's getting close to a C rate, close to the capacity rate. I mean, not bad. I think it should be alright. It should charge in, well, less than 2 hours, I'd say. You can do the math. Probably, about 2 hours or a bit under. So that's pretty good. Not bad at all. I can also calculate efficiency of the charge circuit on that, and while it's sitting here charging, I might just get some temperature numbers. What's the hottest point on the board? Just make sure it's not getting too baking hot. We normally see about 70 to 80 degrees Celsius in one point on the board is fairly normal. Yeah, we'll see how we go. Okay. I don't know what to say at the end of a video, but I guess normal stuff. If you want to leave a comment, go for it. I'll reply back to you, obviously. And suggestions, if you want to see something else tested, a particular model, any of that sort of stuff, feel free to request. I'm just testing for you guys, really. Well, my own interest. I really like seeing what's inside these things. But yeah, most of it's for you guys to see it, and so we can all learn a bit more about the things we're using. So yeah, feel free if you want to see a particular device opened up, and we'll get right into the bottom of it and test just everything we can, or anything you want to know about it. Yeah, let me know. Go for it. Cool stuff. All right, cheers guys. See ya.